So exercise 1-1. What is the main purpose of this exercise? Well, they say, let us consider certain payment streams. We have a payment stream here, which I call case 1, and we also have another payment stream a bit farther down, which looks like this, which I call case 2. So 2 different types of contribution payment streams. And in both cases, they ask us to compute U of N. So goal, find U of N, which is also exactly what we call the terminal present values. So aka terminal present value. And what do we mean by that? Well, what we mean by terminal present value is given any payment stream, we want to stand at the last time point, N, where the contract ends. We want to stand here and look at the accumulated value of all the earlier payments summed together at time N. So where they've gathered all the interest and so on, including the payment at time N. So that's our goal, find U of N. Now, what are our assumptions? The assumptions in any exercise are those things that you may use during the course of the exercise to solve the problem. So this is, I like to call it the assumption toolbox, because if you just gather all of your assumptions in one place, then you can always go and look in the toolbox for stuff that you can use when you want to solve a problem. So let's look at the assumptions in this exercise. Well, first of all, we notice that the I is just an I, and they don't say anything about I being a function. So I is a constant. So I is constant. That's nice. And also, it's quite implicitly assumed that I is different from 0, because we divide by I in the denominator here. We're asked to show this result. So if we're asked to show that, then I cannot be 0. So we also assume that I is different from 0 quite clearly. Another assumption is, well, luckily here we only have to consider the contribution payments, C, because apparently the benefit payments are 0. So benefits are 0. And that's nice, because that means we only have to think about stuff that have to do with contributions. So those are our assumptions. And that was the assumption box. Now, one more thing. Which definitions do we know? Defs we know. Well, the first thing that we know is we do have an expression for the present value U of t. So let's just write that up, just because, well, we actually can find it in the book. So on page 3 of the book, we can see that U of t is given by 1 plus the interest to the t minus s multiplied by C of s minus B of s, summed up for all time values s ranging from 0 to t. And that's very nice to know. And actually we can just work a little bit further on this definition based on the fact that from our assumptions we know that the benefits are 0. So B equals 0 means that this sum actually does not have to include B at all. It's just the accumulated values of the C of s. Wow, wasn't that great? Okay, so what's the next thing that we can think about? Which other definitions do we know that we should probably throw into the definitions box before we start solving the exercise? Well, there are a couple of other things that we're actually asked to look into, because we are asked to look into a, n, and a dot dot n. And these are the initial present values of respectively an annuity in arrear and an annuity due. So we actually have the definition of these in the book. So for just for good order, let's also write them up together. I have the annuity in arrear. So the present value of an annuity in arrear, AN, is equal to the sum of discount factors to the power t, for t going from 1 up to n. And this is equal to 1 minus b to the nth divided by I, where I is the interest rate. And to those of you who have probably forgotten, just if you have forgotten, what's V? Well, V is equal to, V is called the discount factor, and it's equal to 1 over 1 plus I. So it's the thing you multiply by when you want to find the time value of some money that's going to be paid in the future, when you want to find the value of that now or earlier. So that was AN. Let's also get the present value of the annuity due and also write that down. So the present value of the annuity due is, well, almost the same as the one above, except for the fact that the time index is shifted by 1 because all the payments fall 1 period earlier. In Danish, the annuity behind this one is called efterbetalt annuitet, and the annuity behind this one is called forudbetalt annuitet. So everything is shifted 1 period. Discount factor, and this has the value 1 minus v to the nth divided by 1 minus v. Okay, so that's good. Now we also have these. And before we actually get to the problem solving, there is one last thing that I also want to bring up, which is, well, since we're working, as you can already see, with sums of one thing lifted up to the power something, where that something keeps changing, then it's a good idea to also recall what we know about geometric sums. So let's just bring that knowledge back again. So what do we know about geometric sums? The thing we know about geometric sums is that for a different from 1, we have that the sum of a to the power s is the letter they use in the book, to the power s, for s ranging from 0 all the way up to t. Well, this sum has the value 1 minus well, I actually prefer the first one they write in the book. So it has the value a to the t plus 1 minus 1 divided by a minus 1. And if you're interested in how this is proven, you can just take a look at the book. So this is all stuff that we do before we start the exercise. Just write up everything we know, because it's nice to have it all in one place. And it's also nice to just review everything. Now, in the future, you can just skip this part and just go directly to the solution. But I really like to have this part because, you know, it's just a good way to start off exercise solving. It's write up everything you know, write up the goal, write up the assumptions, write up the definitions, and then you're ready to start playing in your playground.